Hi, my name is Glenn Weinreb, and I am going to talk about a data acquisition hardware and software system for Windows computers called instruNet. This miniature USB-based card cage system accepts a variety of cards which directly attach to sensors, including voltage, current, resistance, thermocouple, thermistor, RTD, strain gauge, load cell, LVDT, pressure, and flow. There's not a specific card for each type of sensor. Instead, all analog input channels have universal inputs that attach to all types of sensors. The method that we use to obtain high accuracy is to place the noisy microprocessor in an external box. The card cage is mostly signal conditioning amplifiers that electrically are very quiet and have several microvolts of internal noise when doing low-level measurements. The maximum sample rate is 166,000 samples per second for all channels. For example, one can digitize 2 channels at 83K each or 3 at 55K each. Several different wiring boxes easily bolt to the cards. The i510 works well with thermocouples. The i511 includes B and C connectors, and the i512 works nicely with strain gauges. 8-pole anti-aliasing filter daughter boards are available for those who desire low-pass filtering. Shown here is a 1 kHz filter. instruNet is available in 4, 8, 12, or 16 slots. So shown here is an 8-slot system. However, in most cases, one can start with the i555, which includes everything one needs to get started. It provides 8 differential voltage inputs, 4 voltage outputs, and 4 digital I/O, along with free strip chart recorder software called instruNet World. This software digitizes, displays, and saves waves to disk. Alternatively, one can program in C or Visual Basic, or work with MATLAB, Excel, Origin, LabVIEW, or Daisy Lab application software. Setting up a sensor is easy. One starts by running the instruNet World software shown here. Each row corresponds to a different channel, and one can have up to 256 channels. We'll now open the Quick Setup dialog. The wiring diagram to the right shows how to wire your sensor. For example, a thermistor would look like this, and a quarter bridge strain gauge would look like this, and a half bridge strain gauge would look like this. The sensor type is selected in the first menu. We will start with a pressure sensor. In the second menu, we specify the sensor's electrical interface. Some pressure sensors have a voltage output, whereas others, these are voltage output sensors, whereas others output current, and some output a millivolt signal given an excitation voltage input. We will select the -5 volt to +5 volt electrical interface. In the third menu, one selects units. We will select millibar and tell instruNet that full scale is 2000 millibar. We'll also tell the graph to show 2000 millibar full scale. To reduce noise, we'll tell the system to average each point for 0.0166 seconds. 0.16. This corresponds to one 60 Hz power line cycle, and averaging for this exact duration causes the positive parts of the sign to cancel the negative. For more accuracy, one calibrates using these buttons. We will now press the Update button to lock in our changes. Currently, a half-hertz sine wave generator is attached to this channel, which we see plotted here in real time. At the lower left, we see the sensor updating in real time. We'll now tell the system to digitize 100 points at 10 samples per second per channel. Clicking the Digitize button closes the sensor setup dialog, opens the record page, and starts digitizing. We can press the Stop button at any time to stop, and press the Save button to save waves to disk. One can click the Network tab to return to the list of channels, and click here to enable more channels for digitizing. We'll now go back to the record page, click Start, and digitize more channels. This concludes our tour of instruNet. Thank you for watching.